everyone, thanks for watching LaurieWired, and in this video we're going to look at our compare or CMP instruction inside of our ARM assembly. So this is used to actually set values inside of the CPSR or current program status register based off of the comparison between two different values or operands passed to this instruction. The CPSR register is also set by other instructions that we've looked at in the past, for example, add or sub, but CMP is really often used before branching statements, which we'll get into in the next tutorial probably. So let's open up our ARM assembly reference and see how it works. So this is our reference manual, and you can see our mnemonic is CMP for compare, and then we're going to take two register operands, or optionally you could use an immediate value for this instruction as well, but I'm just going to use the register operands right now. So what this is actually doing is it's subtracting the value inside of our RM operand from the value inside of our RN operand. So it's basically like RN minus RM, and then it's going to set the CPSR register according to what the resulting value actually is. So let's take a look at that in CPULator and kind of see how that works. So I'm going to open up my CPULator and let's set up a couple example values. Maybe do move into R0, the immediate value 4, and then we'll move into R1, the immediate value 5, and these are going to be the numbers that we're comparing. And let me add my comma here. So now let's do our CMP instruction. So it's CMP, and then we'll do R0, R1. So what this is actually doing, let me put in a couple comments here so it's clear. It's actually doing R0 minus R1. So the reason it's doing that is based off of whether the result of this is negative, positive, or maybe 0. That's how you'll know which number is actually bigger. So let me add a couple more comments. So if R0 is greater than R1, so we'll just do a little C-like pseudocode right up here, then this implies that the result is going to be a positive number. Let me just copy my statement right here. But if R0 is actually less than R1, then our result is going to be negative. Finally, if R0 equals R1, this implies that the result is going to equal 0. So let me add a couple equal signs so it makes sense. And I think that should be good. So based off of this should look really familiar to you because we've looked at the CPSR register before. And remember that we have a few different flags inside of this that stand for positive, negative, or 0 results. Let me pull up our CPSR reference, and let's just refresh our memories on what the different bits inside of the CPSR register are. So these are going to be the ones that the CMP instruction can optionally set. So the first one is our negative condition. If this result, let me pull up my CPULator. If our result of these two comparisons right here is going to be negative, then this N condition, or this bit, is going to get set to 1 for true. However, it's going to be 0 if the result of this comparison is going to be positive. Similarly, if you look at the 0 condition, if the result is 0, meaning that R0 and R1 hold the same value, then this is actually going to get set to 1 or set to true. Let's take a look at this in action and just see that happening, and pull up the CPSR register in binary so we can see these bits get set. So let's go back to our CPULator. I'm going to compile and load. And let me pull up actually our initial value And we'll just go over to our rapid tables to convert this to binary. So we've got our 32 digits. And remember, we're working in a 32-bit architecture, so it's nice enough to pad all zeros on the left-hand side. Let's pull up a new tab. So this is our original CPSR register value. You can see all the bits up here are set to 0, so like the carry bit, the overflow bit, the negation bit, and all of those others are all set to 0 up here. But now let's do step over to add our values inside of our registers. So let's do step over 1, step over 2, and now we're going to see our comparison, so keep an eye on the CPSR right here. We'll step over, and now you see we've got a different value right here. We have an 8 in hex at the end. So let's copy this, and let's see which bit actually was set. So we'll paste in here, and this is our new value compared to the old value. Looks like we've just got one bit at the very end that was set to true. And let's see what that bit stands for. So the bit at the very end is the negative condition flag. So that means that the result was negative, so it set that bit to true based off of this comparison. Which makes sense because the constant value 4 is less than the constant value 5, meaning that the result was -1 or a negative number, so that negative bit was set to true. Now let me go back to my editor and let's change our values right here. I'm actually going to swap these. Let's do the value 5 here and the value 4 here. So we actually expect to get a positive number this time. So we expect that the negative bit in our CPSR is not going to be set to true. So it should be set to 0 or false. Let me compile and load one more time. And we do step over. Let me change our result again. So this was our current program status register value. And now we're going to do our compare instruction. So step over, and it looks like we have a different value and the negative bit is actually not set. Let me paste this into our hex calculator right here and convert this. Let me copy this. So it looks like these two bits are not set, but the third bit is set to true. And let's go to our CPSR reference and see which bit that is. So it looks like we have these two bits are set to 0, but our carry condition is set to true. So our carry bit was set to true because our first operand was actually larger than our second operand. So when we performed that subtraction of the second operand from the first operand, it checked to see if we need any borrow to actually be able to perform that subtraction. But since we didn't, that carry flag gets set to true to signify that we didn't need to borrow anything for that subtraction. So let's move on to one last condition where both of our operands are actually equal and see that 0 flag getting set. Let me go back to my CPULator. And what I'm going to do is I'm actually just going to change our R1 register to contain the immediate value 5 as well. And let's just watch this happen real quick. So let's compile and load. And it's going to reset our registers. Let me also get rid of our old CPSR. So let's step over and step over one more time, and our registers are updated. And let me step over and let's do our comparison. So now we have another value for our CPSR register. So let's throw this into our hex calculator and convert that. And let me paste that inside of here. So now we have two flags that are set to true, so let's see what those are. The first one is our negative condition, so the result was not negative, so that didn't get set. The second was our 0 bit, so our result actually was 0, so if you remember, these two values are equal. So this 0 bit gets set to true right here. And then our third bit is going to once more be our carry bit, since we didn't need to borrow anything to be able to perform that subtraction. This is going to be really useful for our next video when we get into branching statements, which is how we're going to perform our if statements and loop statements inside of our assembly. And we're going to use the values of this CPSR register to decide which branch we're actually going to take. So thanks so much for watching LaurieWired, everyone. In this video, we looked at the compare or CMP instruction inside of our ARM assembly, and we saw how it was actually subtracting the two operands that are passed to it that can be registers or optionally a register and an immediate value. And we looked to see what the CPSR register was set to based off of the result of that subtraction. So this is going to be very useful for our next branching statements. So thanks so much for watching LaurieWired, everyone, and I'll catch you in the next video. This one has a lot more big fish than I remember.